Hello, it's John again, and it's been a couple of days, I think, 2 or 3 days, since I recorded the last video, and it was left where the maths weren't working out properly and stuff like that. So instead of me recording my fumblings and rumblings and pulling my hair out, oh pity you can't see that, and all that, I've figured it out, but I wanted to explain to you what the problem was and why it was happening. So this is effectively what was happening. So here's a spreadsheet of what was going on. So we have time. So this is each frame that the lunar lander cycles through. So basically, if you remember, we stopped it working out when it was looping round. We put a wait in there. We was waiting for the raster line to go off the screen and then work everything out. And so this is every frame, every 60th of a second, yeah. So, and I've got how many? There's a few, look, 400. So that's a good 3 or 4 seconds, right? And what I'm saying is, this is what we're starting off with, the vertical velocity, right? And this is the that's the actual velocity, because we've got the test in there if it's greater than 512. And then this is what we was working out, because we was doing an 8-bit arithmetic, it was effectively doing an integer. And so what we're saying in time frame 1 is where we set everything up, yeah. Time frame 2 is where we, because there's no thrust, yeah, we increase vertical velocity by the gravity, which is over here, yeah. And because it's not greater than 512, it's at 8. But then we add on here, we add that 8 onto here, right? So that's why it's doing it divided by 256, because we was only adding the whole numbers together. So it would have been 0 plus 60, which is equal to 60. What we really need it to do is to work out the fraction, yeah. And the reason why that is, the orange line is what we work out if we do an 8-bit addition, because you can see it goes 60 60 60 60 60 60 60 60 60 for a fair while, look, for a fair while. So if we're doing 30 frames a second, it's on 60, even though I'm pressing the thrust key for, that's half a second, for over half a second. So I'm pressing the thrust key for over half a second, or sorry, not thrust key, just let it drop. So I'm not doing anything, I'm waiting for it to drop, and it doesn't drop for over half a second. And it was ever so strange. And then when it did drop, it dropped pretty sharpish, yeah. And that's what's demonstrated here, because it doesn't drop, and then drops, but it's dropping in a straight line, like it's really sharp. And then when I apply the thrust, it goes flat again. So it goes down, 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 stop. And you, what? Down, 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 stop? What's going on there? And then it'd start going up, and then it go up quicker, and then go up quicker. And we don't want that sort of straight lineness, because effectively it was straight line in the curve. Really what we want is this nice smooth curve, Yeah. So what I've done is I've changed the maths, but I'll put the maths back so you can see what I was getting. But now what it does, because it's now including the fraction, when we apply it to the sprite, we're only taking the whole number, right? So effectively we're saying 60, 60, 60, 60, 60, 60, 61. After, how many frames is that? 9 frames. And then 61, 61, 62, 62, 62, 63, 63, 64. So it's already starting to go up the slope. Yeah? And that's what was happening. It was driving me nuts. And I thought, why is it doing this? So I had to do this to work it all out. So what I'm going to do is I'll load it up so you can see. I've also done some other stuff as well, and I'll get to that in a bit. But I did it because I didn't want you guys getting bored, because, you know, watching me trying to think it through is like watching paint dry. Anyway, right, so we're in the main thing, and what I've done is at the addition, yeah, here I changed it from an 8-bit to a 16-bit, yeah. But what I'm going to do is I'm going to rem that out, and I'm going to put it back to the 8-bit so you can see what was going off. Yeah, so we'll go home. I'll copy that because it's almost identical. Right, so add 8-bit, so we're Lunar Lander Y plus the velocity back into Lunar Lander. Alright, so I'm going to, because I've put a loop thing in here as well. Where is it? That's it. So I'm going to rem that out, and I'll get to this later. So I'm producing back what it's doing. So it's waiting until the end of the screen raster line and then performs the task. Right, so here we go. F5. And watch what it does when it drops. It's like it just stays there and then drops even faster. Right, are you ready? Here we go. So it just stays there, look. I'm not pressing anything, just stays there. Just stays there. Forever. And a day. And it was because of that mechanics, and it was driving me nuts. So what I did was I changed it to the 16-bit maths, but the problem was the 16-bit maths were adding low and high numbers. Had adding an address with a value. So here we go. So add, that's 8. Here we go. So add 16 bits, and it's address, value, address. Address, value, address. And there wasn't a 16-bit addition which was address, 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 because all our numbers are in memory locations. So what I've done is I've created one. Now, so here we go. So these are my two new libraries. So we've got add 16-bit, and it's address, 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 and I'm addressing them as words. So we don't have to put the low and high, low and high, low and high. I can understand why Derek did it, but I don't need to do it for this particular thing. And I've done the subtract one as well. So if we go back to the Lunar Lander, I've remmed it back in, haven't I? Yeah. If I run it now, it should start dropping, and dropping smoothly. You know, it accelerates smoothly. So here we go. must have broke it. I must have broke it. Oh, John, I did break it. Let's put it back. It's me test, isn't it? My up here, right. It's this here. That's why. So we'll just get rid of that. We'll leave that as it is. Right, so I'll put it back to the 8-bit. Here we go. I'll explain that. I'll explain all this in a bit. Right. So it should run. Here we go. Drop. Drop. Look how fast it's going. And I'm applying thrust, right? And it just stops. It stopped just at the bottom, look. Let go. Stopped. I've pressed it. Right, I'm going to keep it finger on it and let go. So I'm going to let it drop. Right, so here we go. It's going to drop. And it's straight away, look. Press it, stops. Then let go. It drops. Press it, it stops. And that's not the way to play it. It was driving me up the wall because I couldn't control it. So we'll make it work out the maths using my new library routine. So that's it. That's the 16. Put in the remove the 8. So if I run it now, and you'll see an instant difference. Right, here we go. Straight away it drops, look. So I put me, and it slowly returns, and it's smoothly going back down, and smoothly going up, and smoothly coming back down. And it was just a case that we've got to keep the fractions in mind when we're working out the x and y. Even though they're integer values, we've still got to use the fractions as part of the calculation. So another thing that I've done is that before we could only press thrust or left or right, yeah? So you could only do one of those 3 operations, yeah? That's what we could do before. But I've changed it now so that you can do both. So you can thrust right and thrust left while thrusting up at the same time. Alright, and the reason, and the way I've done that is I just created another sprite reference. Yeah, so we've got our, where is it? Yeah, we've got our thrust sprite reference here. So I've created another one called maneuver, and the maneuver one just shows the left and right thrusting, as the thrust one is showing the thrusting at the bottom. And what I've done down here in the testing is it tests for that mask. If it's not equal, it goes to the next one. If it is equal, it works it out. But instead of jumping out of it and carrying on, I make it test for another control, and another control, another control. And I've added another one here, which is no input. Basically, if nothing's being pressed, it finds out if that, and then it clears out the 2 sprites so it doesn't show anything. So that, and it's made it a lot easier to control, because thrusting and then you want to do left, you have to let go of the thrust and do left, and because of the way it was just dropping like a stone. So the other thing that I've done, well, I've just rendered it out now, and you'll see, is when it runs, right, is that it's difficult to control, right? So I'm just going to try and simulate landing on that pad, yeah? See, as you can see, the lander's very difficult to control, because as soon as I take my finger off it, it starts dropping like a stone. Yeah, look, see, just took my finger off it just for a second. Right, and the reason for that is because we're running the calculation 60 times a second, because we're following the frame rate, and that's what this white line is down here. The white line is how much processing time out of the 60th of a second we're using to do all this, and as you can see, it's not a lot. But as soon as I let go of the thrust, for example, right, I only have to let go for a quarter of a second, and that's 15 frames, and 15 frames means it moves dead quickly. So what I've done is I've created a frame looper, a frame jumper, right, which is here, and basically what it does, it counts the number of frames, right, and so as this loops through, I've got a skip rate here of 7, so I'm skipping every 7 frames. So what it does, it comes in, sets up tests for the raster line being at 255, which is off the screen. I change the background to become white so I could see how much computing power was taking, and then I load the game loop frame tracker, which is set to 0 because it gets initialized, and if it's equal to 0, then it bypasses it. Yeah, but then I add 1 to it, and then I AND it. I AND it with the frame rate. So I'm saying 7 frames, and in fact that shouldn't be branch if equal, that's not equal, because what I wanted to do is when it loads it in, I want to make it do it on the 7th frame. Yeah, so when it adds 1 and it ANDs it, if it's frame 8, that's what I want it to do, branch if not equal. So it loads it in, and if it's not equal to 0, I want to bypass it because I want it to work out everything on the 8th frame. That was it. So I load the game frame tracker, add 1 to it, and then I AND it with 7, which is the least 3 significant bits. So if it's 7 plus 1 is 8, then it stores, then it becomes 0 because it's an AND of 7 and 8 is 0, stores it, and then this fires through. So when I run this, you'll find that the responsiveness is slightly hampered, but it's a bit more controllable. And what we can do is that frame tracker number, for more experienced people, we can make it work out on more frames per second, which means it's more responsive. So here we go. So it's dropping, look, and so it's a lot slower, look. So what we'll do is, instead of it being every 8th frame, we'll drop it down to be every, so 7 is the 3 bits, so 3 is the 2 bits, so we're going to drop it down to every 4th frame. So now what's happening is every 4th frame, so in 60 frames a second, every 4th frame is the one that it works it out of, and it should in essence make this a little bit more responsive for the human without causing the computer to slow down. There we go. So I'll put the thrust up. There you go, I smoothed it out, look. And that's because we're not calculating it on every frame, and the whole point is to be able to do that. That's what I was looking for. Now this is showing how much computer time is being taken up, and the reason why it's flickering is because the thin line is the frames that we don't calculate any of the coordinates on, and the thick frame is when we actually run through it. So this is far easier to manage. But what we can do as well, let's see what it's like if we miss every other frame. Alright, so this is now going to calculate on every other frame. What did I do there? So instead of calculating 15 times a second, it's going to calculate at 30 times a second. Before we was calculating at 60 times a second, and it was just too much. So this is 30 times a second calculation. So we're trying to simulate we're landing on that. Oh no, it's still a bit too, it drops too quick. Yeah, look, it's dropping too quick. So we'll put it back to 3, because that seems to be the right balance. F3. Yeah. That's better. What we and the reason why it's reacting to is because we've got big numbers in thrust and gravity, and we can easily change them. Come on. Ooh. Yeah, that's much more controllable. Yeah, and it's going quicker, look, because I'm not pressing it. But it also means that we can have hard, medium, and easy difficulties, and it's just by changing that number, which is pretty cool, you know, that we can do that. And we can change this. So I mean, I did it on, well, on 1 was every other frame, but if I end it on 2, for example, that means that it wouldn't be working it out on every other frame. It would be working it out on every 4th frame. Yeah, because we'd be moving where the bit is and stuff like that, and we could make it work out on the 8th frame and the 16th frame and stuff like that. So we could work it to the other end. And so let's see, is that everything that I did on here? So you should be all caught up. Yeah, maneuvers, talked about maneuver. Right, so we can get rid of that because don't want it. Right, so that's basically caught you up. So we're 23 minutes into this video, so what I'll do is I'll call it a day on this particular video, and the next video we'll start looking at trying to put in the collision detection in, and do that and make that. I've also been thinking about, because if we do well, let me do it. Right, so what I was trying to show you was Jupiter Lander, right? Because we're trying to simulate this game. And what it's got is when you get close to, look, it zooms in, So, and then when you get too far away, it zooms back out, look. So we can try and do the same thing. I quite like this feature. So that is something I'm going to look at as well. So in the next video we're going to implement the collision detection, just to implement the collision detection. Right then, if you like this video, click that like button. If you disliked it, fine, hit the dislike button. Always leave me a comment. I'll put this on GitHub as always, so this version will be on GitHub. And if you want to become a patron of mine, please do so, because all the money that I am collecting goes back into the channel. And with that, I'll talk to you in the next video. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.